Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your red shifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So, Ro. Last time we talked about the moon and the past and the future. In this episode, we're going a little bit further into the future.
Just a bit.
And ultimately to the end of the universe. We'll stop at some sort of more imminent events that we can expect, which will start to make astronomy as we know it, I guess, and life on Earth change somewhat significantly.
Yeah, thankfully we won't personally experience any of these things.
We've talked before, I think, about how as the Earth sort of jiggles about on its journey around the sun, and also as the sun moves around the galaxy over a longer period of time, that our night sky will change. Yeah,
so we're very used to seeing the North Star, as we call it, or Polaris, in the Northern Hemisphere. And in the Southern Hemisphere, the Southern Cross is used as a similar navigation point. But, like you say, that's not always going to be the case. So right now, when we, in the Northern Hemisphere, look to find our way north, we look for the constellation the Great Bear, we look for the Plough, and then, or a lot of us do anyway, then navigate our way to Polaris. But 1,000 years from now, when no one currently listening to this podcast is still around, but the future generations of their family, maybe.
Or if you get frozen, I guess.
Yeah.
And reanimated is the important bit, but you know.
Then the North Star will not be Polaris anymore. We'll have a new North Star, and it will be Gamma Cephei.
I wonder if they'll still call Polaris at that point.
Yeah, I don't know. I mean, it would make sense for it still to be referred to as the North Star. But it isn't Polaris.
Yeah.
Will that be a strange hang-up? Or will Polaris end up with a new name? Who knows? And then a bit later, if we look ahead to about 2,370 years from now,
right,
the comet Hale-Bopp will return.
All hail Bob.
Named after two astronomers, Mr. Hale and Mr. Bopp. One of which, Bopp, I believe, was an amateur astronomer.
Oh, okay, that's nice.
They found it at the same time in 1995. Probably quite a lot of our listeners will remember it because it was very, very bright in 1997.
I remember it well.
I'm sure. And it was the brightest in a very, very long time. And it gets pretty close to the sun. It's a long orbit comet, but it gets like 0.9 AU to the sun or something like that.
Wait, sorry, okay, so...
Which is,
so it's like the Earth's orbit.
Yeah, which feels pretty close for something that comes from so far out,
Yeah, but we've got to wait another 2,370 years for that to come around.
Yeah, well, like I said, it's on a very big orbit, so it's not anytime soon.
So, from us to the Battle of Hastings, we have to wait to get a new North Star. And then if we wait another 2,200 years, we get another new North Star. What's that? Iota Cephei. So we've gone from Gamma to Iota.
Yes.
Cephei.
Yeah, that's 3,200 years from now.
So is Cephei a constellation?
Yes.
Okay, and then they've named the stars Alpha, Beta, Gamma. Is that kind of the...
Yeah, that's typically how it works for constellations.
Okay.
Yeah.
So that's not too far into the future then. 3,000 odd years. I mean, I guess it's...
I mean, it's a long way, but considering where we're going...
Yes.
It's not too far in the future.
Yeah, so if we then wait until 10,000 years from now, that's when things start to get a bit weirder, because the alignment of the Earth's axis changes over time relative to its orbit. So in about 10,000 years' time, in the Northern Hemisphere, we have a hotter summer than the Southern Hemisphere's summer. And it is exacerbated by the fact that in the Southern Hemisphere there is more ocean. So we will actually then end up getting even more extreme weather in the Northern Hemisphere in a hotter summer.
Presumably that will have a lot of consequences for the weather on Earth as a whole.
Yeah.
Sounds pretty nasty.
Yeah.
For perspective of 10,000 years means, or at least the order of magnitude of 10,000 years. By 20,000 years, Chernobyl will finally be safe.
Okay, well...
So that's kind of where we're at in the distant future, currently, with our the path that we are on.
So if you buy real estate,
so we're talking
now...
like a really long time at this point. By the time that we're seeing these effects on Earth.
And by safe there, I guess you mean like it's basically no different to anywhere else, as opposed to like you don't really want to live there at all. But that's also not far off. 25,000 years, the Arecibo message arriving at its destination.
Yeah.
So what is the Arecibo message?
It's the most powerful message that was ever beamed into space.
Okay.
It's a transmission of radio data that was sent on the 16th of November 1974. So by 25,000 years from now, it will be received at its destination, the globular cluster M13, or Messier 13, on the opposite side of our galaxy.
Was that why they picked there? Just as far away as possible?
I think so, yeah.
So if anybody listens,
just
then...
to prove that they can, really.
Did they just beam in, like, whatever was in number one at the charts that day, or...?
What was number one?
Well, in the UK, on the 16th of November 1974, Gonna Make You a Star by David Essex, apparently. In the USA, it was Whatever Gets You Through the Night by John Lennon.
Well, anyway, they didn't beam any of those things.
Okay.
So that was by the by.
John Lennon would be pretty good.
They sent a pictorial message
Right.
showing where we are and who we are, but not really who we are. It was basically a stick figure, what DNA is, and some biochemicals of life. It was a 3-minute message.
That is actually, that's a song. 3 minutes.
Despite taking 3 minutes, it was about 1.6 kilobytes.
Right.
Which is not really very much.
No, not at all.
I'm sure it was significant for the time, but 1.6 kilobytes is not very much these days.
So I've got a picture in front of me. I would recommend people go and look at it. I think I've seen it before, and it's very. When you say it's 70s,
well,
it does look sort of like Pong-esque. It's got sort of Space Invader vibes, which is probably not a good vibe to have for a message to aliens.
Well, yeah, you can tell it's only got 1.6 kilobytes.
I can see the stick figure. I think I can see something that might be representing the solar system.
Yeah.
Although how the aliens are meant to work this out at all, I'm not sure. I feel like when people make these messages, it's like they need to be sent to a planet where they are really into cryptic crosswords or something.
Yeah.
You know?
Well, it takes 25,000 years from now before that happens.
Okay.
So, assuming they decode your cryptic crossword very, very quickly, we're waiting 50,000 years at the earliest to receive a reply from them.
Okay. So... And if they don't get it, then... and they send a message saying, sorry, we didn't get it, then we've got to spend another 25,000 years.
Yeah.
Okay. Well, by 100,000 years' time, basically the entire night sky no longer is recognisable to us.
Yeah.
We've moved around in the galaxy. Constellations...
Yeah, they're completely different.
They're out the window.
I mean, they still exist, but...
None of us are Capricorn or anything. We're just...
Yeah.
Yeah. We'll have to have new things. And about that same time, VY Canis Majoris, which...
Big star?
Is or was the biggest known star? Did it get usurped by UY Scuti? Is that...
I don't know, there are always a few stars vying for largest. It was Stevenson 18 at one point.
Right.
After UY Scuti, I think.
Okay.
I mean...
And is it all like...
Realistically...
We're not entirely sure because there's errors.
Yeah, the uncertainties involved in measuring the size of very, very large stars are not insignificant. So when you have, multiple stars, there often is a crossover, where it's all very well saying this one is bigger than this one, but it might not actually be like that. Because of your uncertainties and just, So I don't know what the current biggest star in the universe is.
Okay, and nobody does know, I guess. So it's all couched in.
I mean, I guess nobody knows, but there probably is one that is hailed as the biggest star.
Okay.
Yeah, I mean, but I'm just saying.
Yeah.
We should be careful. When we try to label these things, because it's a very big star anyway, and that's all that really matters.
And so by about 100,000 years from now, VY Canis Majoris will probably have not just gone supernova, but gone hypernova.
Yeah.
That's how big it is.
Yeah. It's just a fancy word for big supernova, really. That's what it really is.
Super explosion.
A supernova.
Yeah. And that is also the point at which, every year there is a chance that Yellowstone National Park will explode in a supervolcano, covering the Earth in volcanic clouds and smothering us. And we'll go into a winter or whatever.
Yeah.
And also every year we're just hoping that we're not getting hit by a giant asteroid which will kind of do the same thing.
Yeah.
Amongst other things. By 100,000 years from now, we'll have rolled those dice enough that it's pretty likely that one of those events will have happened.
Yeah.
So that's not great. That's pretty apocalyptical.
I'm not sure that's really a human issue.
Yeah.
If we made it that far. But like you say, every year we roll the dice on these things.
Mm-hmm.
Just because by then it's highly likely that we will have experienced one of those things. That does not mean that it won't happen next year.
No.
Or in 100 years.
Yeah.
Or 1,000 years, not to be doom and gloom.
No.
Or anything.
And we're going to go more apocalyptic as we go further into the future, so buckle up.
Yeah, I mean, less apocalyptical, just to simmer it down a little bit. By 1 million years, then Betelgeuse will probably have exploded.
Okay. Which, considering
everyone says that every year.
Yes.
Sometime
between now and 1 million years from now.
Yes, yeah. But by 1 million
years, you never know. You're rolling those dice again. You're rolling the dice.
And at this point as well, the pyramids, Mount Rushmore, other really big stone monuments that are really robustly built are probably the only things that will survive from humankind.
Yeah.
Which I was quite impressed by that, really.
The pyramids?
Yeah, like 1 million years from now, and they'll still...
Yeah, I mean, I guess it's basically erosion at that point, isn't it? Because also I did see there's a famous pyramid called the Black Pyramid, which is built really shoddily, which is why like the inside bit you can see, the outside bit's crumbled, so it's not going to be around in 1 million years' time. Because basically they built it out of bad stuff, they built it badly, and it was very soggy where they built it.
Okay, that doesn't sound like the best.
No, and I'd be a bit miffed if somebody built that for me and put me in there. But, but the pyramids of Giza are pretty solidly built, so they're going to be lasting for a while.
Yeah, I just think that's so impressive. Anyway.
I mean, how old are they now? 4,000, 6,000 years old?
Drop in the ocean.
Yeah. So that's 1 million years. And an extra 500,000 years. We'll have Gliese.
Gliese 710.
Gliese 710. And that,
which is a star.
So that star is going to be coming reasonably close, but I would say still not that close.
Yeah.
1.1 light years away from us. And all from the sun. And And even though it's not that close, it is incredibly close, to the extent that it will actually affect the Oort cloud around the solar system. And that will then cause, as, you know, when you start to jiggle around in a whole bunch of rocks around the outside of the solar system, we'll then start getting comets sent our way, and they'll end up coming into the inner solar system. And
a whole bunch of icy, rocky comets heading in the direction.
Yeah.
It'll be a busy place.
Yes.
Yeah, okay. So that's 1.5 million years from now, but let's travel further forward.
Okay.
What's going to be happening in 8.4 million years in the future?
Well, I'm glad you asked, Joe, because in 8.4 million years, Lagios 1 will return to Earth. And I know what you're thinking. What is Lagios 1? And is that even how it's pronounced?
Well, I want to know why it's 1. Does that mean that there's a 2?
There are 2. It might be Lagios because it's like laser geodynamical satellite or something like that.
Ah, okay. Yeah, I see where we're going.
So, NASA, in 1976, sent up Lagios 1. I think in 1992, Lagios 2 joined it. So, these are really weird satellites. You can't really talk to them. There's no instruments on board. They don't have any form of sort of navigation or, you know, there's nothing on them. They're just balls.
Right.
They're brass balls which have studded into them like little crystals, little bits of silica. And these are essentially mirrors for lasers. So people on Earth can fire laser beams, pulses of lasers, up at these satellites. And when they get returned to Earth, they can then give you very precise measurements of distances. So then you can work out things like the surface of the Earth, kind of thing. Now, they're in super stable orbits.
Yeah, apparently so.
Why it's going to take 8.4 million years for these to come down. But the weird thing about Lagios 1, I don't know how many different ways I've pronounced this now, is that Carl Sagan was involved.
He gets everywhere.
He always does. And when he does, he likes to put a little plaque in there. So it's a bit like the Voyager 1, or the Voyager plaques, discs. But it's a lot simpler, to the extent where I can almost understand what's going on, having read the description. But it's a little plaque that has the Earth, like a map of the Earth as it is now, not with countries, but just land masses. And it's got a bit that's like 8.4 million years before that, what we thought it would look like, or we think it looks like, and not a guess, but what we think the Earth will look like in 8.4 million years from now. I'm not entirely sure what it adds, if somebody was to receive it.
What about in 10 million years then?
Well, by this point, another star called, you're going to love my pronunciation of this one now, T-Pixidus?
Pixidus, yeah.
So
I would have said anyway.
It's 3.3 light years away, or it will be, and that will go supernova, which will then bombard the Earth with gamma rays.
Oh, that's pretty delightful.
So we'll have a nice sterile Earth.
Get your sun cream.
Yeah.
Won't do very much, but...
Get your lead concrete bunker. But, that's 10 million years away, so we don't need to worry about that too much.
Okay, well, we've got quite far to go, so let's skip forward to 250 million years from now. We have a new Pangaea.
Nice. I like a Pangaea.
This is a similar time for the sun to have done a complete orbit of our galaxy.
Right, okay, so it takes a while.
250 million years. So, yeah, it's a pretty long time.
Okay.
Yeah.
Right, and then in 600 million years, it may be the case that with the moon moving away from us, we will no longer be able to see any total solar eclipses. Which is probably not the chief worry at that point, if there are any worries left. But,
Bit sad, though. Earth is very special and unique in that it is able to experience total solar eclipses. We are just so positioned at a distance from our star and a distance from our moon that happens to be the right size. So that when it passes in front of the sun, it completely blocks out all of the light.
And we talked briefly in our moon episode about how some people have suggested that actually being able to have a total solar eclipse is a potential indicator of whether you could get life on exoplanets. It's kind of interesting.
Yeah. Yeah, it seems that moons, large moons, could be important for life's development and continuation or thriving. So, yeah. As the sun gets older, we've talked about how it's going to change as well.
Mm-hmm.
So, by the time it's older, it'll be starting to progress into becoming a red giant. So by 1 billion years from now, the sun's luminosity, or essentially its brightness, is going to increase by about 10%, which might not sound like all that much, but the surface of the Earth is going to get quite hot because of that. Right. So the temperature is going to go up to about 47 degrees Celsius. I'm not sure what that is in Fahrenheit. Maybe you can do that conversion.
Over 100 degrees Fahrenheit, but not sure.
Yes, quite a bit over.
That doesn't sound great for us.
Pretty hot, yeah. And our oceans will start to evaporate. So then we'll have a pretty moist greenhouse.
I think that's also significantly above the point at which if you lie in the shade doing absolutely nothing, you will still die because you can't cool yourself.
Yes.
So that's something to look forward to.
Yeah, too hot.
Okay.
Yeah.
Well, that's all right because in 2.3 billion years, the core of the Earth will have frozen, and that's the end of the magnetosphere. So then...
whole lot more troubles coming our way.
Yeah.
Once that core has solidified, then we'll lose our magnetic field, which protects us from so much. From the sun, but also from the universe, lots of cosmic rays and stuff. So, yeah, Earth will be fine, but life would not find Earth to be a comfortable or tolerable place at that point, really.
Yeah, so then another 500 million years and the surface temperature reaches 147 degrees C, not 47, which is probably not that far off 300 degrees Fahrenheit. And then by 3.5 billion years from now, the Earth basically looks like Venus today.
Yeah.
So we've talked about
Delightful.
how not delightful Venus is. So
Yeah, so at this point, Earth really is maybe not the most interesting. I mean, not to make out like Venus isn't interesting. Current day Venus is interesting, but the bigger picture is maybe more interesting than planet Earth by the point that it's turned into a very hot rock doing not very much. By 4 billion years from now, Andromeda and the Milky Way have coagulated.
Ooh, lovely.
Into a new a kind of galaxy, which one might refer to as Milky.
You make it sound like you don't like that name.
Yeah, it's just a bit of a mouthful.
Would you prefer the Andromy Way?
Andromeda? Yeah, I would actually. I'd prefer the Andromeda Way. And it also feels more appropriate, really. I think, Andromeda is the bigger galaxy.
Okay.
We just want to put ours at the front because we're egocentric, really. Yeah. Either way, no matter which way around you say it, even the galaxy will be unrecognizable.
Right.
By this point.
And how's the sun doing at this point? You said we're starting.
Fine. I mean, it's getting on.
Okay.
But it's still going at 4 billion years, and it probably won't crash into anything because everything is so far away from everything else that even when galaxies collide with each other, often the stars don't collide. You'll have a very small number that do because that's how statistics work. But chances are the sun won't collide with anything, and it'll just continue on its merry way, being a star.
It's
bit later on, though, that really won't be the case. By 5.4 billion years, the sun has exhausted its hydrogen.
Okay.
Which is the fuel that it needs.
Yeah.
To produce light in its current form.
So at that point, the best fuel it's got is like helium. And above, so it's starting to churn through its heavier elements.
So it progresses onto helium burning at this point, and this is when it starts to form into a red giant.
Okay.
So starting to get a bit unhappy.
Okay, and then I guess it's, as the name would imply, it starts to get bigger.
Yeah, and we don't really know how big it's going to get. It's definitely going to encompass Mercury, highly likely Venus, possibly ours, but possibly not.
Okay.
But it's definitely going to start to engulf quite a lot of the inner solar system.
Nice.
And anything it doesn't engulf is going to be suddenly a lot closer to it, so...
So does that happen as soon as it stops burning hydrogen, or does it need to wait a little bit?
It doesn't expand immediately. It's not an instantaneous thing. It takes a bit of time to expand. Yeah, so by 7.9 billion years, the sun's radius will be about 256 times bigger than it is currently. So that's a lot bigger.
Yes.
But that's not happened immediately.
Yeah. Yeah, okay.
It will start to expand, and it will take a bit of time to reach its maximum radius. Yeah.
Okay.
So that's, in the grand scheme of things, happened kind of slowly, right? 5.4 billion years starting to form a red giant. 7.9 billion years, it's really
Biggest.
big. By 8 billion years, so
Okay. A little bit after its
only a
biggest.
little bit after, it's turned into a white dwarf.
Right.
So at this point, it's blown off its outer shell into the solar system,
yeah.
or what remains of the solar system.
So also not great, even if the Earth is not absorbed. It's not great time to be on Earth.
Not great. And what remains the center of that is the white dwarf.
Okay.
So a carbon oxygen-y star.
Okay.
And relatively speaking, quite small. It's about half the current mass of the sun.
Okay. So then it settles into white dwarfhood. And for the next however long.
It's all that remains. It's not producing anything. It's just emitting all of the heat and energy that it has, letting all of that out.
Right.
Into the universe.
Until it's basically lost all of it.
Yes.
Right.
And that takes a really long time. It is thought that then, a really, really long time later, 14.4 billion years from now, which is about 6.5 billion years from when it became a white dwarf, it will become a black dwarf.
Right, and that's when it's then, basically lost everything.
Yeah, it's invisible because it's not emitting anything.
And how...
Which is why, we'd never see one anyway. But also they take a really, 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 really long time to form. It's emitted everything. There's nothing left. You can't see it.
And I guess that's interesting because
there is still something there, but it's not interacting with the universe.
a black hole's really big, so you can see things like gravitational microlensing and things look weird, so you can see where a black hole is without being able to see a black hole.
Yes.
But I guess a black dwarf is nowhere near that. It doesn't really do that kind of thing.
No.
Right. And that's 14.4 billion years from now.
Yes.
How old is the universe currently?
About 14 billion years.
Okay, right. Okay. So, from the beginning of the universe to now, we need to wait again for the sun to have gone through its entire life and ended up with just a husk. Okay.
Yeah. So a pretty long time, really.
Well, it's not that much longer later in the grand scheme of things, 20 billion from now, that we could get our first end of the universe.
Yeah.
The Big Rip.
Yeah. So we don't really know we don't know how the universe is going to end.
No.
There are various schools of thought on this, and therefore there are different time scales for which this can happen. So yeah, if we work through all of them, they're not all going to happen and be the end of the universe.
Yes.
But we can work through them in order of when, time scale of when it would happen. So yeah, the Big Rip, 20 billion years from now.
Yeah. That's the point at which dark energy has essentially meant that all little tiny pieces of matter are infinitely far away from each other in a way that really just makes your mind fall out of your skull, based on the expansion of the universe, and so the universe is just done.
Yeah, we know the universe is expanding. The reason that we give to this, which is more a name than anything else, is dark energy. We don't understand it, what it is, what it does. But something is making the universe expand, and we call it dark energy. Is pretty much what's going on. And if you take that to the limit, what happens if the universe expands forever and ever and ever? What happens eventually? What is the end? The end is everything is infinitely far away from everything.
Yes.
Planets are infinitely far from planets and stars. The things that make up the planets, the atoms, are infinitely far away from the other bits that make up the planet.
Yeah.
So the atoms are infinitely far away from the atoms.
Which means there's now no, like, molecules, because they can't interact with each other.
Yes. But then also, your electrons are infinitely far away from the nucleus of your atom.
Yeah. And the nucleus
the
of the atom
protons are infinitely far away from the neutrons, and etc., etc., etc.
and the quarks within the
Yes.
nucleon. Yeah.
So nothing can possibly happen. Everything has been ripped apart.
Yeah. And
Lovely.
yeah. So that's one potential end. That's 20 billion years from now, roughly. But the universe might not end there. At which point we have, in 100 billion years, all of our local group of galaxies begin to start to swirl together and make one mega galaxy. And that, at this point, stars beyond that galaxy will become no longer visible. And that's a process that's going to take 1 trillion years for it to really all merge in a blob.
So getting into silly numbers at this point.
Yes. More silly numbers to follow, but not too many more. Because at this point, all things are just sort of fading, really.
1 trillion years from now, all of the gas clouds that we know that stars form in have gone.
Right, yes.
So we can't make any more stars.
Wow.
It's all a bit sad, really. Between 1 trillion and 100 trillion years.
Depending on who you ask.
Yeah, a lot thereabouts there.
So, if it upper estimate is 100 trillion years when we have no new stars, in 110 trillion years, all stars will have died, and the only star things that are left are white dwarfs, neutron stars, and black holes. No actual stars. So, yeah.
Yeah, I mean, I'm sure the people that work on white dwarfs and neutron stars will be crying at you saying, no actual stars, but yes, to all intents and purposes, yeah. It's a pretty miserable universe at that point.
Yeah. No fusing stars. Is that more politically correct?
Probably.
Yeah. And then talking of silly numbers, 1 times 10 to the 20, or 100 quintillion years from now, if the Earth is not absorbed by the Sun during its expansion, then the Earth will have spiraled in towards the remnant of the Sun and been swallowed up. But
yeah, I just feel like that's not really a massive problem at this point. Really.
No, I'm not sure what massive problems there are at this point, really. But I guess the end of the universe.
But, I mean, yeah, that's a long time for the Earth to have crashed into the Sun, really. You know?
Yeah.
100 quintillion years.
I guess.
That's pretty good going.
Circular motion is very good, isn't it? like you say, things are pretty spaced out. No
Yeah.
pun intended. So we talked about the Big Rip and the expansion of the universe, but that's not the only potential end.
Oh, there are various ideas. We don't know what the end is going to be, really. I mean, there are definitely people who pick sides.
Yeah.
But yeah, we don't know. The Big Rip is pretty popular. There's also the Big Crunch. Can you guess what that is?
We've had the Big Bang, and everything
Yeah.
explodes, so I guess the Big Crunch is the opposite.
Yeah, pretty much.
Okay.
A lot of the names get big something in front of it to match the Big Bang.
Right, okay.
A kind of like combination of Big Bang and Big Crunch is the Big Bounce, which isn't really necessarily an end of the universe, but it fits with the idea of a universe that oscillates, a universe that will come into existence and then crunch and come into existence again. I mean, I guess people might take different opinions on whether or not that is the same universe or not, I suppose, but, you know, you get the idea.
I'm pretty sure I came up with that when I was a teenager.
Yeah, I think a lot of people have come up with the idea.
No, I did.
To be honest, it doesn't feel like it's a huge step.
Should have patented it.
I don't think you can patent the Big Bounce.
Okay.
You
Has anyone
could
tried?
possibly have written a paper on it. But
Okay, yeah.
although it was probably already well written about by the time you thought about it as a teenager.
It's nice. It's like poetry. It rhymes.
Yeah, I think that's why people like it. Yeah. There's also the inevitable heat death of the universe.
Oh, I love the inevitable heat death of the universe.
That's my favourite, actually.
Yeah.
It sometimes gets called the Big Freeze.
Nice.
To give it a name that matches
all the other ones.
The other ones. Which I appreciate, but I prefer inevitable heat death of the universe.
Yeah, I think also there's something about the words inevitable heat death of the universe that just kind of fits with it, because the Big Freeze sounds like something happens, whereas the inevitable heat death of the universe is just like slowly something will cease to happen.
Yes.
And that will be it.
And it also doesn't feel so scary.
Yeah, I guess.
It just feels like it's inevitable that it's going to happen.
It's going to happen. But
you know, like...
Yeah.
You know what I mean? It just gives vibes that are like, just chill.
Yeah.
Just chill.
I think there's also something about, you know, like the Big Rip. You're like, whoa, Big Crunch. Ah, Big Bounce. Ooh. But when you just like the inevitable heat death of the universe, you're like, well, death sounds scary, but what's the heat death? You know?
Well, let me answer that for
Okay.
you, as if you didn't already know. Basically, we've reached a point at which there is a minimum temperature in the universe. It's not necessarily 0. But energy is not being kind of transported anymore.
Right. Yeah.
It's reached a maximum entropy state, if people are into that kind of science. It was originally suggested by Lord Kelvin, believe it or not.
He's got a name that has something to do with temperature.
Yeah, he sure does.
What a coincidence.
He proved that the universe was not infinitely old as well.
Nice.
And he suggested the inevitable heat death. It just feels pretty appropriate, really, I think.
Yeah.
You know? But, yeah.
I think there's also something quite nice about the, how will the universe end? Like, it just sort of dwindle out, you know, just like...
Yeah.
Which probably doesn't make for great, like, sort of conference proceedings, you know. I've done more modelling on how long it'll take for sort of nothing to be able to happen, you know?
Yeah, I suppose I'm glad I'm not writing them. Yeah. But there's another one, which you actually taught me about today, so I'll let you...
Yeah, well, I've never heard of this before, but...
It feels like a cheat to me.
It is, but it's also not, because... So, all of these things are based on sort of models of things that we understand or think we understand.
No, we don't understand, and we don't think that we understand.
Okay,
that's not true.
That's not true. But, you know, the big rip is the expansion of the universe. The big crunch is if the universe was to contract, kind of thing, you know. Heat death is eventually energy just gives up. But
a lot of them are based on our current understanding or lack of.
Yes.
Of dark energy.
Yeah.
Ultimately.
Yeah.
But we at no point ever really say or claim or even think that we understand dark energy.
No. So, and in cosmic uncertainty, basically they're like cards on the table. We really don't understand dark energy. Dark energy must have behaved differently at the beginning of the Big Bang to how it behaves today. And so if it's changed from then to now, it could maybe change again, in which case the big rip and the crunch and the bounce and the freeze, they could all be out the window. It could be the big, literally anything else. Things get weird, and we have no way of knowing. And the universe isn't actually that old currently, so you can't just extrapolate from what data we have now to how the universe is going to end.
Yeah, and I'm on board with them there. I mean, I think the thing about it for me is that, and this is, it's a question that you get asked a lot by people who are into science, right? Especially it's especially hard when it's kids who are enthusiastic.
Right.
It's like, where did the universe come from? How's it going to die? They're like two questions you can guarantee you're going to get asked.
Okay.
Right. Where did the universe come from? Probably the Big Bang.
That's only a probably.
Right, like, it was probably the Big Bang.
Where did the Big Bang come from?
Right, exactly. A perfectly sensible question to ask after that. What's going to happen to the universe at the end? We don't know. And because of that, I find it really difficult to care. Like, I don't... And maybe this isn't the best way to end this episode, but...
Well, it's better to end it this way than to start it this way, I guess.
It's just like... It's just so far removed from what we can understand. It just feels like a question we can never answer.
Yes.
Because, like you say, we do not and we cannot collect enough information and enough data on this because we're around for a tiny, tiny, insignificantly small amount of time at a point that's not really that far into the life of the universe, probably. And so because of that, it's like, well, if we can never answer it,
yeah,
why should I worry about it?
Yeah. Yeah.
There are more interesting questions to investigate that can be proved or disproved.
Fair.
You know? And I feel like I'm on board with the people behind cosmic uncertainty, because they're basically saying, we don't know, right? They're basically like, we don't know and we can't know.
Yeah.
Which I'm on board with. But the thing that annoys me about it is you've decided to research this and your answer is we don't know and we can't know. Like it just feels... I can't get my head around that. I'm like, well, so why? Why are you doing this then?
Yeah, I also wonder in that case, because you've then sort of gone ahead and you've said, it's not like, oh, well, there's these different models, we don't know. And people have then said, well, there's evidence for this or that, or there's a lack of evidence for these other ones, so it must be this one. Whereas with cosmic uncertainty, you're like, well, there's sort of like not even like we don't really know, like, how the universe is expanding necessarily, although we know it is expanding, because that seems to change every now and again when we do new measurements or whatever. It's like we've got another rationale as to why we really have no idea. So I guess I should just abandon this field when I've done that. I'm going to go and research something
I guess
different.
that's what I'm saying, right? Because
Yeah.
are they? Are they then doing that?
No, they're definitely not.
Exactly, of course they're not. My issue with it is not really an issue. It's just like on a personal level, I cannot imagine doing that.
Although maybe these are people that also do the Big Bang, so they're still going to look at things about the Big Bang.
I mean, they're cosmologists, right? I mean, there's a whole bunch of stuff that goes on in cosmology. It's not like that will be their only area of research. I'm not, and I'm also not knocking it. Just because I don't think it's something that we'll ever get an answer to, that doesn't mean that it's not worth doing, because I'm just one person who's not an expert in cosmology. Maybe there are lots of people who are experts in cosmology who think that we will one day get an answer to this. And even if someone who was a big, hailed kind of scientific genius thought that it wasn't worth doing, that doesn't make it not worth doing.
Yeah.
So I'm not dismissing it as a research field.
Mm-hmm. I
am purely dismissing it as a research field that I could ever find any level of interest in myself.
Yes.
Someone's got to do it. Someone's got to do these jobs.
One thing that is interesting as well about cosmic uncertainty is the other ones are not going to happen anytime soon. But cosmic uncertainty kind of opens up the opportunity that tomorrow dark energy decides it's going to do something different. And now half of the Earth has fallen off. And Derek, head of cosmology, has just enough time to say, I told you we didn't know. And then the universe ends.
Yes. That sounds like it's a sci-fi book.
Yeah. Pretty short one. But I
mean, I think that's highly unlikely, but yes, it certainly does open up the possibility to a very different pathway for the universe. And it can't be dismissed because we simply do not understand dark energy beyond giving it a name.
Yes.
So it can't be dismissed as a possibility. You can't really chuck out anything, like you say, when you completely don't understand something.
It does make it hard.
Anything could happen, really, and you can't really prove that that's not the case.
Yeah.
So it is interesting, and yeah, it's not one that I had ever heard of before. So
yes,
I wonder how commonly known it is.
Yeah.
Out there. hopefully it's something that our listeners might have learnt as well, because I thought it was pretty cool.
Yeah. I do wonder though. I guess part of this is also like the Big Bang is such a different set of everything as far as we are aware of it working at all, to now that like the laws of the universe kind of have changed, right?
Yeah, I mean, the universe has changed. The forces that were significant earlier in the universe are not the same as the forces that dominate now. The universe is completely different. Well, thank you for the whistle-stop tour of the future of the universe. I want the end of the universe to be the inevitable heat death.
Yeah, and if not that, then I want it to be the bouncy one.
The bouncy one, yeah. But yeah, it's been a fun and wild ride. Earth lasted pretty long. I'm still very impressed. 100 quintillion years.
Yeah.
Assuming it survives the red giant phase, I think is spectacular.
Yeah.
Really, really spectacular. So, yeah, I guess that's something to look forward to.
Yeah, with a few supervolcanos along the way. So, yeah. But assuming that no supervolcanos occur between now and when you're listening to this, then
we'll see you next week.
Yeah.
Yeah. We'll progress on our story through the solar system, which hopefully will still be here next week.
Hopefully.
Cosmic uncertainty won't have worked against us.
I hope not.
Yeah. See you next time.
Bye. So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and if you like, you can leave us a nice positive review as well. It really helps the show and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.